Today you will be learning lesson 4.5 on writing function rules. And if you struggled in lesson 4.2, this kind of will help you with that. Go through that rule a second time. Okay? So a function rule, as we already learned, is a method or procedure describing how to solve a problem. Okay? Method or procedure describing how to solve a problem. Okay? What it really is our equation. Here we have a rule that you guys should know. If I'm dividing fractions, it's the same thing as multiplying by the reciprocal. Okay? That's a rule that we can use every single time we have a dividing fractions problem. Okay? As long as B, C, and D are not 0. Okay? Remember the reason why B, C, and D cannot be 0? Because you cannot divide by 0. And in that problem, here we have a B on the bottom, zero, a D on the bottom, so it can't be 0, B again on the bottom, so that can't be 0, and finally that C on the bottom, so that can't be 0. So according to that rule, okay, if I'm taking 2 divided by 3, okay, or 2/3 divided by 6/9, it's the same thing as taking 2/3 times that reciprocal of 9 over 6. Okay? A rule. So a rule for how to solve the problem. Lesson 4.2, like I said, this reiterates all that, okay? That for a linear function, that rate of change, okay, is our coefficient. And if you didn't notice when we were substituting in for n into this equation, right, that every time we did that, it was the number that was paired with 0. Okay, so if they're giving you ordered pairs, this constant right here is the number paired with 0. Okay, now if they're not giving you ordered pairs, like you're going to see today in these word problems, what that means is that's our starting amount. Starting with. The problem. Okay? A landfill has 5,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste, right? What is the function rule that represents the total amount of waste after m months? So this time we're not using that x and y, we're using variables that are related to the problem. So we're using m for months, about, okay, our total. Okay, so for our total, I'm going to use the letter T. Okay, if you want to use Y, you can use Y, but I'm going to use T to represent that total. Remember when you're doing word problems, sometimes it's easiest to pick the variable that makes sense with what it's representing. Okay, so our output. Okay, which one is our input and which one is our output? Does the number of months depend on the total, or does the total depend on the number of months? Okay, the total depends on our number of months, so that makes this T our output. Equation then I know should be T, or the total, is equal to something. Okay, so what do we know? We know that each month, and if you remember the word each, that tells us it's our coefficient. So each month, it adds an average of 420 tons of waste. So that 420 is our coefficient, because that's what's happening every time. So 420m, okay? And then what we started with is it already had 50,000 tons. So that number is our constant. That's our starting amount. Okay, so today, rather than giving you just ordered pairs, you have to figure out the coefficient and that starting amount, that constant that you're going to add at the end. Okay, remember, starting amount for the coefficient, easiest way to look for it is the words per or each. Okay, so a kennel charges $15 per day to board dogs. Upon arrival, each dog is given a flea bath that costs $12. Write a function rule for the total cost of n days for boarding plus the bath. Okay, so we're talking about two things again, making it that function, n days, and we're talking about the total cost. Okay, so they again didn't give me a variable for this total cost, but I'm going to choose C, and we need to decide which ones are input and which ones are output. Okay, so does the number of days depend on the cost, or is the cost determined by the number of days? Okay, the number of days determines the cost, so that cost is our output. Okay, so when I write my rule, it's going to start with C equals. Okay, so now back to the rest of the problem. Okay. The kennel charges $15 per day to board a dog, and then each dog is given a bath that costs $12. So you have to figure out which one of those is your coefficient, which one's the changing every time, and which one's your constant, which is your starting amount. So no matter what, in order to take that dog to the kennel, it has to get a bath, and then they charge $15 per day. So that 15 is our coefficient. So we have 15n plus that original bath amount of $12. Right, now this problem asked me to do one thing more. It asked me to figure out how much it's going to cost for a 10-day stay. Okay, so what they're really asking me to do is sub in 10 for n. Okay, so to figure out that total cost, I'm going to plug in 10 for n. So C equals 15 times 10 plus 12. Okay, solving that equation, 15 times 10 is 150 plus the 12 original for the bath, and we are at 162. Okay, so C equals 162. Since it's a word problem, don't forget we need to label, and we're talking about cost. So the cost for a 10-day stay is $162. Okay, so linear always has that set formula. Nonlinear is a little trickier. A nonlinear function is a function whose graph is not linear. Okay, so these ones, the graphs are not going to be a straight line. Okay, so if you tell right here, it curves. Right here, it's like a W, so it's got two curves. Okay, these aren't straight lines, so they're a nonlinear function. Now writing rules for them is a little trickier. Okay, these do not have a constant rate of change, so that equation doesn't work. Okay, so we need to come up with two options. Okay, your choices are either to have x to a power or a number being taken to the power of x. So you have two choices. Okay, x to a power, so x with a number up here. Okay, or a number to the power of x. Okay, two options. Okay, so in order to figure out which of those it is, and these are still going to be rules, so it's still going to be your output equals. Okay, relationship between the x's and the y's. Okay, if there's a relationship there, okay, this means that x is being taken to a power. Are you taking that input times 3 every time? Are you taking that input times 8 every time? Okay, and you'll see that when we look through the next one. Okay, if that doesn't work, then you want to check if there's multiples of the same number in the outputs. Okay, so that would happen if we have something being taken to a power. Because if you think about that, if I have 2 to the second power, I get 4. Okay, so their x would be 2. Okay, But if I have negative 2 to that second power, I also get 4. Okay? So we're getting that output, okay, based on our power of x. Okay? Write a function rule for the area of a triangle whose height is 4 more than twice the length of its base. So for this problem, we first need to think about how you find area of a triangle. Okay, and the formula for area of a triangle is area equals 1/2 the base times the height. Okay, so in this problem, okay, I'm writing function rule for area, so we're talking about A, but I cannot have 2 other variables. So I need to look into that problem, okay, about am I going to keep B or am I going to keep H? So we need to figure out which one's going to stay and which one's going to change, okay? So it tells us the height is 4 more than twice the length of its base. So height is, remember the word is means equals, okay? So the height is, so the H equals 4 more than, so we're going to add 4 to twice its base. Okay, so what that tells us is B is going to stay B in that problem, but the H is going to be replaced by this. So what I have right now is A equals 1/2, B stays B, times 2B plus 4. Okay, now when you're writing a function rule, if you can, you don't want it to have parentheses. You want it to be in that simplest form. So what that means is I need to distribute this 1/2 B. I get area equals, I'm going to take 1/2 B times 2B, 1/2 B that, okay, B times B, we're taking those like terms, is B squared, and 1/2 of 2 is 1. And remember, if our coefficient's 1, we don't write it down. So that's what we get for that part. So we're at A equals B squared, and then 1/2 B times 4, we can multiply those numbers. 1/2 of 4 is 2, so we have plus 2B. Look at this equation, okay? It no longer has that formula of y equals a number x plus a number, okay? Now we actually have 2 variables in this one, and the other thing you should notice is that we have a power. Okay, so this is my function rule. Okay, so the next thing they want me to do is to solve that function rule to figure out what the area of a triangle is whose length of the base is 16 inches. So they're asking me now to solve that equation when I sub in 16. So I have A equals 16 squared plus 2B, which B again is 16. Okay, so in order to solve that equation, when I solve an equation, I follow the order of operations. So I need to square that 16 first, okay, which gives me 256. 16 times 16 is together. My area has a total of 288. Okay, again, we're talking about a word problem, so I'm not done until I label it. The label here was inches, and area is always labeled in units squared. Oopsies. Squared. So there's my 2 answers. I have my function rule and my solution. Okay. Now for that problem, okay, let's graph it. Okay, and when you graph something, okay, remember you need to make a table. Okay, for this problem, they gave us numbers to use for my table. So remember our equation was area equals B squared plus 2B. Okay, The first one, they want me to plug in a 1. Okay. So when I plug in 1, area equals 1 squared plus 2 times 1. Okay, remember you should show your work in there, so I wrote a little too big for myself, but 1 squared is 1, 2 times 1 is 2, and 1 plus 2 is 3. So for my graph, my first order pair is at 1, 3. And if you look at this, okay, this side over here, this is 30, that means this one's 15. So it's going by 15s. Here, this one's 2, so this one's 1. So I'm on this first line, but I'm only up at 3. So I'm very close to that axis. Okay, and I plug in the next one. Okay, this time I'm plugging in 4. So I have 4 to the second power plus 2 times 4. 4 to the second power, 4 times 4 is 16, plus 2 times 4 is 8, and 16 plus 8 is 24. So at 4, my graph, okay, goes all the way up now to 24, which still is not to 30, okay, but it's close to 30. When I plug in 7, here just so you can see easier on my graph, right? We have to take 7 squared plus 2 times 7. 7 squared is 49 plus 2 times 7 is 14. We're at 63. Is that 7, 63, and 7's in between the 6 and the 8, so 7, we're up here at 63. Okay, and the next one they want me to plug in is 10. Okay, so when I plug in 10, okay, 10 squared plus 2 times 10. 10 squared is 100, plus 2 times 10 is 20. So at 10, I'm all the way up at 120. We're at 10, I'm all the way up here at 120. So I have 4 dots, one right down here, one here, one here, and one here. Okay. Now when I go to try to connect those, okay, if I look here using my line tool, okay, if I try to connect all of those dots, if I connect those two, I miss those two. Here I connect the last one and the second one. Here I miss the last two. So what that tells me is that this function is non-linear. Okay? So it's non-linear. Okay? The reason you can tell is because the graph is not a straight line. Or because in the equation, of those two options will tell you that this is a non-linear function. Okay, now before we finish, one thing I didn't do here is on my graph. Remember, when you are graphing, this did represent a word problem. In every graph, you need to have title and labels. So down here, the input is B, which remember was representing the length of the base. We were talking about the area, okay? And for our title, okay, I could label it area, but I can't just say area because that's what I have here, is that we are talking about the area of triangles. Okay? If it's linear, look for that constant rate of change and your starting amount, and then you have y equals a number x plus a number. If it's nonlinear, remember you have to check through the set of rules. Okay? Is your x going to be an exponent? Okay? Or is your x going to be taken to a power? And that's writing function rules.